We're going to skip practice your skills, right? And then we go to 275, cosine law. That's where I want you to go right now. You might still need it. You might still need it. Yeah, keep it. So, cosine law, I'm going to, at the very top, tell you the two scenarios where you're going to have to use cosine law graphically, okay? It's this. Let's say you have a triangle like this, and you know all three sides. That's called an SSS scenario. So side, side, side. Like when you deal with triangles, we often use capital letters to refer to what information is given. Okay. Or this other scenario, if you have a triangle like this, right, you will be given a side, the angle in between, and another side. So SAS. Right? So if you notice that you have two sides and the angle in between, so it could be anywhere, right? You could be giving you these two sides and the angle in between, SAS, you should be thinking cosine law. Or if all three sides are given, you should be thinking cosine law, right? Okay, another way of knowing when to use the cosine law is you don't have a pair. Right? You don't have a pair. Sine law, you do have a pair. Here, like all three sides are given, you don't even have an angle to have a pair, so you can't use sine law here. If you're given this circumstance, right, there's no side across the angle to get a pair out of that. So you either remember that these two give cosine law or you don't have a pair, okay? So let's highlight cosine law, right, because that's kind of a big deal. Working with the cosine law, in section 7.1, you use the sine law to solve for unknown side lengths or angles of oblique triangles. Don't be scared by oblique. Oblique is anything that isn't a right triangle is an oblique triangle. Okay, but only if you knew the side lengths and an opposite one. And right, sine law. Right, so sine law, highlight that. You could only do it if you knew the side length and an angle opposite one of them. Right? That's basically your limit. You're limited when you're only having sine law. You're limited to those cases where you have pairs. What happens if you want to know the side length or angle in other situations? There's another trig law you can use called the cosine law. Okay. With cosine law, you can solve for cosine law, the third side length of a triangle, if you know two side lengths and the angle between, right? Any angle if you know the length of the three sides. So this refers to this scenario, and this one is SAS. Okay, so I gave you a graph up there to distinguish, so you don't have to just go by the description, you can actually just look at the graph. So I would strongly suggest you have that on your study sheet. Okay, Ethan, just continue. We're on page 275 in our booklet, okay? And now are the formulas. Here are the formulas that are significantly different from what you see on the formula sheet that you're provided with. Okay? So let me just go all the way to the bottom. You should have a lot of room there, the bottom of 275. And I'm going to split that. I'm kind of going to give you a guideline. It's going to be not quite evenly split up. I'm going to go close to this B here and draw my line there. Okay. So we're going to have two columns essentially here with formulas. And we're going to I'm going to use the letters that are given by this triangle up here. Okay. So the first case is the SAS, right? If you have an SAS scenario, okay, you're going to use this formula right here. So I'm going to use the, I would recommend one different color if possible, right? So I'm going to say this is the pattern, a squared, right, is equal to, just copy for now, b squared plus c squared minus 2 times b times c times cosine of angle A. Okay. So this is the one you would want to use if you're trying to solve, like if you're given an angle, right, you would be solving for the side that is across this angle. That's always what I want to make sure you understand. And these are the other two sides, right? BC and BC shows up again. These are the other two sides. But if you're trying to solve, if you're given an angle and the two sides, right, B and C, you're going to be solving for that side length that's across that angle. And I'll give you some examples later on. So the same thing can be said about b squared. Let's say you want to find side B. My bad. Then on this side, you'd have a squared plus c squared minus 2, and watch, I'm going to use a and c again, times a. The dots represent times, by the way. I just want to make sure you have that clear, okay? 2ac, which is just following this pattern, you multiply them here, times cosine, that never changes, but now it's going to be angle B, right? So if angle B is the one you're given, you're going to solve for the side that's across from it. Because think about it, this triangle here. If B is the angle you're given, and they give you A and C, right? You would be solving for side B, which is across angle B, right? If you're trying to solve for side A, look at the first example here. They would have, that means you would have known B and C and the angle A, right? Everything on the right side here is what you know. And this is what you want to know. Right? So one last version of this. C squared is equal to B squared. Let's go with A first. My bad. A, not that it matters. Right? C is here, so you're going to have the other two sides, which we call A and B, right? So you square them both. At first, it looks like Pythagoras almost, right? And then it's minus 2 times A times B times cosine of angle C. And then we're going to move over to the right side, which is Sas Scenario, right? How about this? We do this one more time. All three sides are known. SAS, you have side, side, and the angle between. That's how you know it's, and I always go from this side. It doesn't matter if you come from this side, right, or the top. You need to know two sides and the angle in between. You know it's an SAS. Okay. When you have all three sides, all that there's left to do is solve for an angle. Okay, that's all you have left because all three sides are done already. So you can pick which one you want to do first. Okay? So let's say you want to solve for angle A. Cosine of A looks like this. You have to remember, just like in sine law, the angle is attached to sine. Same thing with cosine law. If you determine as cosine law, the angle is always attached to cosine. But notice that in all formulas, there's only one angle showing up, right? In sine law, you could have more than one. So this is what I want you to do here. Draw a longer line like this, okay? And we're going to fill in the formula here. That's b squared plus c squared. And watch this. Angle A is here. That means that you're going to have to subtract a squared at the end here over 2 times b times c. It looks pretty complicated, but trust me, after a while, after practice, it will make more sense, okay? But I'm highlighting here that if you're trying to solve angle A, then you're going to have to subtract side A, which is across from it here. That is the most important step here, okay? So let's do cosine of B. If you would try to find angle B, that would be a squared plus c squared minus b squared. Okay, the side that's across from that angle is being subtracted over. If you copy this to your study sheet, I would strongly encourage you to have these in different color or highlighted. Okay. Last version of this, because there are 3 angles technically to choose, right? That would be a squared plus b squared minus c squared over 2 times a times b. And I think I'm just going to say one more thing here. The one triangle that we're not going to address that cannot be solved is, I'll just make a note here. If you have all 3 angles given, that is a triple A, right? Can't be solved. Like you can do one where all 3 sides are given, but you cannot solve one where all 3 angles are given. It's impossible. So that I feel like that's worth noting. If you ever come across something like that, you know you can't do it. Okay. I strongly encourage you to make sure this finds its way to your study sheet. Okay. And highlight it and everything. Okay. Maybe I will emphasize because a lot of students forget the minus. They add everything, right? And now we can do some examples using these formulas. By the way, we're usually only going to use one version of these. Like we're not using all 3 in every example. You don't have to be scared like, oh my goodness, these are a lot of formulas. I'm just showing you the pattern, right? Since there are 3 different sides, right? There are 3 different versions of this, right? 3 different angles, there are 3 different versions of that. Okay, and I'm always using this as my reference. Like if you're wondering where did he get the letters from, this one right here, right? Okay. So let's go to 276 and let's give this a try right away. And Some students, they like cosine, they prefer cosine law over the other. Some students prefer sine law. That's completely up to you. However, you can't, oftentimes you're not going to be able to, you have to pick the right one. Once you start solving using sine law, for example, you can switch over to cosine law at one point, but at the very beginning, you're going to have to choose. Okay, so here we go. Calculate the side length of A. So they want that side. Okay, you analyze it, right? And you look at it. You're like, wait a minute, what would I use, sine law or cosine law, right? Sine law or cosine law. That's how I'm going to approach things now. Even though you know it's cosine law because it's in the cosine law section, I check, right? I know this side, I know this angle, and I know that side. This is an SAS, right? Cosine law, right? It is a cosine law scenario. Another, right? You don't have a pair. Like there's no pair, so you can't use sine law, right? So there it is. You've now determined that it is cosine law that you have to use. So let's go ahead and solve, okay? Since I'm trying to find this side length, right, I'm going to use that formula where it's a squared is equal to b squared plus c squared, right? It's the other two sides. This could have been x and y, would have been x squared, y squared, right? Minus 2 times b times c times cosine of angle A, right? These are across each other. So what I want you to remember that it's just like, okay, I want this side. This is the side I want. I'm going to make sure this angle is going to be at the end here. And in between, you just fill in. Take one of the sides, square it. Then take the other side, square it. Make sure you put the plus in between. Then it's going to be minus 2 times whatever b is, right? This side times c times cosine of A. That's how I want you to approach it, okay? So A squared is equal to, B in this case is 7.9, we're going to square that. C is 5.2, we're going to square that. Minus 2, I'm going to use brackets here, folks. 7.9 times 5.2, right? So I'm plugging in the values, times cosine of angle A, which is 43 degrees. Like that. And now is where calculator comes in handy, okay? Watch how I am going to do this. I'm going to go 7.9 plus, oh no, squared. Make sure you square 7.9. Okay, we're on 276, Jarrell. Plus 5.2 squared. I hit equal there. And I get 89.45. Okay. And I'm just going to write this down here. 89.45. Use all decimals, or at least 4 if this gives you more than that. But in this case it stops. Now I'm going to go over to this side and do this separately. So watch this. 2 times 7.9 times 5.2. If you have brackets, you can use brackets. Times cosine of 43. And that gives me 60.088, and it keeps going. Right, that keeps going. And now you obviously have to subtract these two. Okay, so I'm going to bring down the a squared because I did this work on the background, right? but I'm really continuing with this. So a squared is going to be equal to this minus that. And I'm just going to go ahead and take what I have on my calculator and just subtract the front number from it, but I know it's going to be a positive, right? I'm just saving some time having to rewrite this. So you get 29.3619 continues. That keeps going, right? Indefinitely. And last step is to get a, you need to take the square root of 29.3619. So I'm just going to multiply this by -1 to get a positive, right? And then I take the square root of it, and that's 5.42. 5.42 is my final answer. And we are in centimeters. Okay. Now, if you have a good calculator, I will save you some time here. I'll show you how to type all of this in one shot and jump straight to here without having to do this in 2 steps. So watch how I do this. Go 7.9 squared plus 5.2 squared. You should try this, right? Minus 2 times 7.9 times 5.2 times cosine of 43. It equals, and you get 29.361, right? Which is what we got here. So it is possible to type this in all in one shot and go straight to here. You just have to practice. And then your last step is to get rid of that squared. So that's when you take the square root. So I take the square root of my answer, and that gives me 5.42 centimeters. Okay. Let's say this happens a lot. Some students you just stop right there. Does this answer make sense? Right. Let's go up. We have a 7.9, we have a 5.2, all of a sudden you have a 29.36. It seems a little extreme, right? So way off what you have there. So you have to remember, you have to take the square root, and that's how you get the answer. Okay, so we've applied, and this was an SAS scenario. We found the side that was across the angle given. Question, do we have a pair now? Do we have a pair now that we've solved for this side? Yeah, we now know 5.42, correct? So you technically have a pair. So if you wanted to now use sine law to solve for other things, you could do that. Okay, and I will show you how to do that down the road. Let's try another one here. This one is an SAS. Yeah, let's give this one a go here. Okay, and then I'll ask you to do one on your own. So we have, this is an SAS, use cosine law. Okay, side, angle, side. We're trying to find R. Okay, this is all I need you to remember. Watch closely, because this is not ABC anymore. You're trying to find that side, so you're going to go R squared is equal to, just take the other two. It's 4.3 squared plus 6.5 squared, right? It's both of these sides squared and added up. And then you go minus 2 times the first one you wrote down times the second one you wrote down times cosine of the only angle that's present in this problem, right? So you put this one here, the second one there, and then it's minus 2 times first and second cosine of 61. And watch my next line, folks. I go R is going to be square root of whatever I get here. You know you're going to have to take the square root. So type this all in. I'll show you how I do this. 4.3 squared plus 6.5 squared. So practice this with your calculator right now because that's going to be important, right? You get 33.639142223. It doesn't hurt to write them all down. Takes you a couple seconds, and then you go square root of that. You might have to press answer, the answer button, and that's 799, right? This rounds to 80. And we are in kilometers here. That's your final answer. So in 3 lines, I was able to solve this. If you're doing this in steps, I can tell you that this top part here, like these two numbers squared and added, would give you 60.74. And this part right here gives you 27.100858. Right? And you'd have to subtract them to get this. And then you get your, okay, Jarrell, I got you. Okay. I'm going to get you to practice this or dismiss you. I'll go over this one and I'll give you the answer to this one. I just want to briefly mention a common mistake that I see. So in this case, you're trying to find y. So you start with y squared is equal to 12.3 squared plus 12.1 squared minus 2 times the first one. You got to be careful because they're very similar, right? You don't want to mix them up. Times cosine of 41. The next line is y. I already, as soon as you just start writing y, here, I'll highlight that, right? Here it's gone, right? It's on because you're taking the square root of whatever you get here. And when you type all of this in, if you can't, you have to figure out there's a way to do this, but you have to figure out your calculator, okay? 73.0531 ... right? It just keeps going like that on your calculator. Press the square root button of your answer and you get 8.55 if you round it. One common mistake that I see is students they forget this negative here and they just go 12.3 squared plus 12.1 squared times this times this times this times this. It's a huge number if you do that, and your answer will not make sense. So you got to watch out for that. I'll give you the answer to this one here. This should be on the side here. C is equal to 195.41 meters. You can't see that because I'm covering it. There it is. That's the answer to this question right here. That's the length of the pond right here. Okay. One thing I'm going to say is I'm going to give you the answer to 3 as well. That right? So I'm going to go to the next page. You can try those 2. And then example 2, we're going to do that tomorrow. We're going to do a triple S. Okay, so this is the answer to example 3. Make sure you try that and it works out to that. It's basically, do I know how to use my calculator and is everything working out for me? Make sure it's set to degrees, right? Oh, How much farther? It is 467.91 meters further. This is the answer to x here, but it is this much further. Okay, so I might take some time tomorrow to go over that. Okay,